your part 2 video for 4-2, rational functions, graphing rational functions. So we're given here, what is the graph of the function f of x equals 2x plus 1 over 3x minus 4? So there are two things that we need to plot in order to get some type of graph for this. I need to know what my vertical asymptote is, and I need to know what my horizontal asymptote is. So for the vertical asymptote, I'm going to take my denominator, set it equal to 0, and solve. So 3x minus 4 does not factor, so I'm just going to go through and solve it. I get 3x is equal to 4, x is 4/3, so I have a horizontal asymptote at 4/3, which is 1 and 1/3. So that's going to be about right down through there. Next horizontal asymptote, I have to look at whether this is case 1, 2, or 3. And this is actually case 3 because the top and the bottom exponents are to the same power. So it is case 3. So I take my 2x over my 3x and reduce that, and I get 2/3. So y equals 2/3 is going to be my horizontal asymptote. And then I would go through and sketch out a couple of points. You could plug in some different values to see what you get. If I plug in, for example, 1 for x, I get a -1 on the bottom. I get 3 on the top. So my 1 is going to be down at -3. If I plug in 0, I get a 4th. So 0 is going to be up at about a 4th, because I have -4, I'm sorry, down at -1/4. 0 is going to be -1/4. If I plug in -1, I'm going to get something that is very much a fraction. -1 is going to be, I have -7 on the bottom. I have a -1, so -1 over -7 is a positive 1/7, so it's barely above the x-axis. So I'm going to get a graph that looks something like this. And then we can look at plugging in things on the other side. So for example, if I plug in 2, I get a 5 on the top and a 2 on the bottom. So 5/2 is going to be 2.5, so that's going to be right there. 3 is going to give me 5 on the bottom and a 7 on the top. So 7/5 is going to be 1.4. So 3, 1.4 right there. And I can go through and sketch that one. You could plug in 4 as well if you wanted to get an additional image of what that's going to be. You can always use a graphing calculator to check. I'm okay with you guys using your graphing calculators through this, or Desmos to help you with understanding what's going on. Please make sure though when you do type this in that you do put the top and the bottom in parentheses of whatever fraction you have. So now we have example 4. It says the cost of removing a pollutant is modeled by the given function where f of p is the cost in millions of dollars of removing p% of the pollutant. What percent of the pollutant can be removed for 78.3 million? So I'm going to set the 78.3 million. I would normally set that equal to my 8.7 p divided by 100 minus p. Now we're actually going to use graphs for this. You could go through and solve this algebraically. You could go through and multiply both sides. This is something we're going to be doing a little bit later on, so I am going to show you the algebra behind this. Because I can multiply both sides by this 100 minus p, which is going to reduce itself there. On the other side, we would have to distribute. So I'm going to get 7, 8, 78.30 minus 78.3p. I need to get my p's on the same side. So 8.7 plus the 78.3 is going to be 87p. So then my 7830 divided by 87, it gives me 90. So that's actually going to be 90% of pollutants removed. Now, if we look at this on the calculator, I'm actually going to do two different equations. I'm going to let the 78.3 be one equation, and the 87p divided by 100 minus p be my other equation. I'm going to see where those cross. So, let's go back to y equals. Clear out the equation that's in there. I have 78.3 as one of my equations. I have 8, and actually I want to put this in parentheses, 8.7, and I'm going to put in an x instead of a p, divided by 100 minus x. I am going to reset my windows. So Zoom 6 will always reset your graphing calculator. But we probably won't be able to see what's going on here because, again, I got 90 as a solution. So I'm going to have to go back to my window, and I need to adjust this. So my x max, I'm actually going to let equal 100. And I'm going to let my y max equal the same thing. Because remember, the y that I'm graphing is the 78.3. And we know that the x was like a 90-something. So now if I take a look at what this graph looks like, there's the 78.3 line. Here's the line coming up for that rational function. And you can see where they cross is the point that I'm interested in. So to figure out where that point is, if you're on the graphing calculator, you want to press second and your trace key, and we want to go down to number 5, which is your intersection. I want to get close to where that actual value occurs. It's asking me for my first curve, which is the blue line. So I press enter. Second curve is the red line, press enter. Guess, you can get close to where you think the answer actually is supposed to be. And then it gives me my intersection. So you can see the x is 90 and the y is 78.3. Well, I'm interested in what the x value is because I know I'm going to get 78.3 for the y because that was the line that I graphed. But this is a way that you could use the calculator to figure that out. Desmos would also work, and it might actually be a little bit easier because it would already plot where those two lines actually cross. Lastly, this is going to be just graphing a rational function. We are going to pick some points. We're also going to use the graphing calculator for this one. This is an interesting one because your graph actually does cross through the asymptote, but the asymptote is still going to model the end behavior of where it's actually heading. So the first thing I need to do is figure out my asymptotes. So for the vertical ones, I need to take my denominator and factor it and set it equal to 0. So I have an x and an x. Factors of negative 15 that add to make 2 are 5 and negative 3. So I get negative 5 and positive 3 as my two vertical asymptotes. So there's negative 5, and there's positive 3. For the horizontals, this is going to be another case 3. So I'm going to have 4x squared over x squared. That's going to reduce to 4. So y equals 4 is my horizontal asymptote. And that's going to be up here. You do need to be able to state where the asymptotes are and back up your work with actual algebra. I am okay then with you using graphing technology to actually get some points to plug in here. I'm just going to do a rough sketch of this. Again, well, here's what it looks like on the graphing calculator. So you can see that. So we have, in parentheses, 4x squared minus 9 on top. On bottom, notice I'm putting top and bottom in parentheses. I have x squared plus 2x minus 15. And actually, I want to, let's stop that. It'll let me. We're going to reset our windows here so you get a better picture of what's going on. See, it looks like we have almost kind of a parabola thing, and then we have those two curves on the side. I am going to zoom out just a little bit here. Again, if you're in Desmos, you can do like a pinch zoom out. So this is going to be a better picture of what you have going on. So we have a curve, we have a parabola, and then we have another curve. You can actually look at the table and see what some of those values are. Let's see. So we're going to have something that looks kind of like this in the middle. And then we have one of these going on this side, and one of these going on this side. So they're not perfectly graphed, but that's enough for you guys to get a good picture of what's going on. There's a concept summary in your book on page 207. Please take a look at that, especially if you need those case 1, 2, and 3 situations summarized for the horizontal asymptotes. That will come up again, especially if you're planning on going on to AP Calc. Go back through, rewatch this video, rewatch the part 1 video, and reach out to me if you have any questions at all.